We are back live with more model-based RL stuff. I left off implementing a hacky version of mu0, and if I recall, needed to train the reward model, needed to fix the action encoder. Let's get to it. Thing. Oh, yeah, this needs to be... Hang on. I see, so the values is going to be different, maybe? Cool. Why does stream not show? There we go. Hey folks. Back to getting this implemented. I'm not sure how mu0 will do versus Dreamer, to be honest. We need to see compute comparisons on stuff. I would like to see if I can at least get it to do something, though. Okay, so these are misaligned. That's sketchy. State.hidden. Okay, so these are now aligned. We're gonna want to predict one ahead like before. So this is gonna be this is gonna be star. Word loss. Define the loss. See how this does. Okay. This does run. Cool, this does actually run. Now we just need to figure out the encoder, I believe. So, do we just have to add a layer? Is that all we have to do? I guess that this should be m.single prod. Okay, and then this is we have to add like a projection. Yeah, we have to add a project. So this is I think there's a better way to do this. I don't think so. So we have this action projection, and then instead of this concatenate here, this needs embed equals coder, and then concat, and then we do this. So you have this action project now. This is the hidden state. State.hidden has to equal this embedding. And then in forward here, we do mu0 something like this-ish, I think. And then you shouldn't have to do this on the rest of them, maybe. I think that's how it works. Let's be tensor, not list. should be one hot actions. Okay, so this will almost be at the point where it could work. This is going to be way too slow is the only issue. Huh? I think what we want to do is... Do we replicate trial? I think we replicate across trials, right? So we only do one set of forward passes, we don't do a double loop. I think I can do that, and I think it'll fit in memory, maybe. Does the LSTM cell not accept batch dimensions? It probably doesn't, right? Dropbox running, only weird thing is SPS reporting's erratic. If you're on dev, that's normal. There's some screwy stuff in that. If you see the new profiling though, it's really cool. There's some things to fix. I'm currently attempting to implement like this, not quite Monte Carlo tree search, but this search-based edition that uses a world model. So I'm gonna see how much progress I make on this. Saturday is a good day to just crank dev. Okay, so this did something. So now we have to do, we should reshape these. We only need rewards into action. Probably how that repeat works, right? No. Is this like a dot gather? Oh, because you're doing it completely wrong is why. So we have the rewards here, which are all 0 right now, lovely. Or the indices are 0. This is IDX's, first of all. I think this is correct. No. Okay, we'll check this, but I think this is the roughly correct thing. So now we have 2,000 actions or whatever. So this is like the full vectorized version. And what, now we have to return the actions instead of the logits, I guess? So we just do like... something like this. Something like this. Okay, so this is at 800K somehow. This is like still reasonably fast. Now we have to look at like how I screwed it up, obviously. But in general, this should make sense. Reward loss is 0. Did reward loss start at 0? I didn't log it. Okay, cool. There is a reward loss now. So I think then we just have to get this correct. And we should actually be good. I'm trying to think if there's anything else I've missed. I don't think there is, though. I guess we just like... let it at least train a couple steps. Okay, so... shape. So now we've got this massive hidden state. It's repeated a whole bunch. So if I go for 0, 0 here, and if I go for 0, so 1, 0 here, yeah, you should give me the same thing. And then if I go for like 0, 1, it should be different? Yes. Okay, so I think I have this correct in the view. So then, one hot tape. These should not all be zeros, right? State.action. Oh, I think it's because there's probably something screwy with the sampling, right? Okay, so let's do it this way. Because if all the actions are 0, yeah, there is variance in the rewards here, right? And there is 0, 1, and 2. There is variance in the actions a little bit. Okay, this says all 0. That doesn't look correct. Oh, the rewards are the same exactly in each. Okay. Yeah, we definitely have something screwy then. Because the action getting appended here, action, this should be mu0 action, right? Yeah, we should not be getting all the same action. Okay, so this gives us separate indices, right? So if I go forward one step, and try something. If we go forward one step, and we only have n equals 1, what happens? Okay, I think that the sanity here is going to be that this should be the same as the original algorithm pretty much, right? We'll have to see what the exact differences are, but this should recover original algorithm perf. Because now this is just going through and you sample logics. There's only one to select. Oh. This is the sanity right here. This will be the sanity. And the way that we make sure that this is the same, we just comment all of this crap, right? No? I guess we can't set the action as well. Okay, so this is the one that recovers perf. Okay, this is also fine here. So now the question is going to be, how is this here different? This hidden state. Okay, wait, this is a different hidden state. Hang on. This is a different hidden. This is state.hidden. exactly did we do this? Embedding, concatenate with one hots. Encoder on observations. And then concat and project, right? They should be identical to before. So what I should be able to do then, this should equal hidden. This should exactly equal the hidden state. Okay, so this is correct up to here. And then cell is called on this, and then the mu0 LSTM state. Which is just H and C, right? That's correct. You call decode actions on the hidden state. It's also correct. So this does look identical to me. Okay, so possibly something else is screwy. Let me just get a random sample that's not from the start. Identical, right? So we got the hidden state correct. And then you get mu0 hidden, logits, values. This take is the wrong one. Yeah, this take has got to be wrong. I think this is it. Hey, welcome. Yeah, that's not it. Still not that. Alright, this is just me screwing up indexing. What are you doing? I'm trying to get sort of a form of mu0 into PufferLib so we can test some like search-based slash model-based RL. Is this it? Yeah, that's still not it. What kind of applications M's is tailored to mu0? Um, well, that's the cool thing with mu0, right? It's not like alpha0 where you need a like a state set and get function for your env. It can kind of just learn it for whatever. So it's a pretty clean way of doing model-based RL with search without needing to have like a state set like you can have with Go or chess. I'm just blanking on how to do this really simple indexing operation, and then we should have something. Why is this like so weird? Isn't it just like this of star? No. Not this either. Tensor processing libraries were a mistake, I swear. So much time spent doing retarded indexing. This is like so unbelievably stupid. It's still freaking wrong. Oh, here it is. Okay, we're gonna just use this for now, and then we'll figure out a better way of doing it. Come on. Okay, dot squeeze. So if I've done this right, this should match the original curve. Roughly, yeah. How does this still not match the original curve? It's like better than before, but it's still nowhere near as good as the original. Is this not identical? Okay, let's try this. This should reproduce, right? Okay, so this is the same error as before. This is the same perf. So let's see why that is the case. So return logits and values. Action gets to be state.action instead of getting sampled. But you just sampled it before, right? And then if I comment this, and I do action like so, does it fix? Yeah, okay, so this is just, I've made a mess somehow, and I'm getting confused, because otherwise this would be totally fine. Action state.action. This is sample logits. It's very weird. Very, very weird. Yeah, so action state action. These are the same logits, are they not? Okay, this seems to work. Now can I do this? No, I cannot do this for some reason. Different curve. Is it? And this is working, but 0.3, 250, maybe there's just variance. That's not as good. Okay. So this is cell on hidden in LSTM state. I guess you can technically do it. You can technically do it this way. Can I just like comment this, comment this? Okay, that's the good one. That's the good curve. Now, we can do this as like okay, this is just too much to think about. This is breaking my freaking brain because I haven't like I've done this in a really messy way and I no longer know what the fuck I'm doing. So let me just clean this up and make this actually all make sense. Um, yeah, there's just too many shitty tensor operations to follow. Okay, so the first thing I need to figure out is the way that these actions work. Like, you pass action at last step, right? And this is going to get the reward. So for the first step, these should all match because you have the same actions from last step. This is really just getting you your initial encoding state, right? And then from there, it can change. Okay. So that makes slightly more sense. Can you not feed multiple? I think the LSTM does require me to do it this way, unfortunately. Here's your action projection. Here's your cell, here's your decode, logits and values. Mu0 actions is the one on the first step taken. Yes, okay. So it's this indexing operation right here, which is a freaking mess, which is just confusing the hell out of me, I'm pretty sure. So I just have to find a better way to do this operation, and then everything will get a lot easier. I don't know why I batched it this way. This was kind of stupid. Want to take one of these each, right? One of these per each. M equals 2. Damn it. Yeah, you can't do this shit because the fucking LSTM cell just sucks. So obnoxious. Okay. Nope, not this. Better. So bullshit. Such bullshit. If this freaking works. Can we not just like fucking do one extra forward pass and not deal with this horseshit? We totally can, right? Hear this. We really just need this actions. gonna drive me insane. Frickin' thing. You know, I start to wonder what the hell the point is of all these fancy ass frameworks when it's like I'd almost rather just be writing CUDA at this point. Almost. It would be really easy, actually. Like CUDA with a couple basic utils would be way easier than this. Okay, this should be the fast one, right? This doesn't optimize anywhere as near as quickly as the other one. Okay. State action gets mu0 actions, values, logits. Mu0 hidden gets state.hidden. How are these freaking different? There's no way. Hidden's different now? I thought we checked that, like, extensively. See? Nope, these don't freaking match either. Okay. How do these not match? How do these not match? You take mu0 actions. You append mu0 hidden. Mu0 hidden comes from state.hidden. Right, and then this is supposed to be right here. Go with 1. So right here, this is supposed to match a rig hidden. Okay, so this matches. This matches, right? No, this doesn't match. What the hell? Mu0 LSTM state, maybe? Ah, you dummy. Right here. Okay, mu0 hidden and hidden now match. Does this give us fast curve? It should give us fast curve. Nope. Still shit curve. Identical logits. LSTMH, LSTMC get updated from here. Where's hidden get updated? Hidden should get updated in here, right? State.hidden. Gets updated there. That's everything. Seems like this should be fine. I guess, wait, log prob? Maybe it's this. No, but log prob. Oh, because this returns log prob of the action. This is why. Log prob state log prob. Yeah, this has got to be it. So you can return logits, but not log prob. Okay. There. That's the fast curve. Good. Works as expected. Finally. Now, next. Next is going to be... First we do this. So 360 at 13 mil. Did I even change anything? Okay, that matches. So this n doesn't matter apparently, at all. I guess it's just really nicely batched for very small networks. And now this is where things can change a bit. Okay, so this is a little bit behind, but not far behind. And how many steps do they look ahead in this? How many steps ahead does this look? Unroll for k equals 5 steps. So then this is valid. So I guess we just need to scale this maybe. And hope we don't run out of memory. See what this does. So we're gonna definitely have to try this on a different end. fully collapsed entropy as well, so this really shouldn't be doing much over, yeah. It's fine. It's generally fine. Okay, let's go to something like Go. Yeah, so Go is a good one here. Okay, so this is like baseline thing. Really doesn't do very much, right? Let's just do this and see see what it does based on this. Can you guide what this is? This is me attempting to get some sort of model-based RL into PufferLib. So I have this like Mu0-esque search thing where for every action, or for every like trajectory, it tries 32 times to generate alternative trajectories. And it tries to see which one is the best before it takes an action. So far, I have not gotten this to really do anything, though. Yeah, this definitely doesn't help here. This is, like, not stable. This is just stuck. Okay. There's one other experiment I want to run on this. Which is... Now that's a fully random search. Yeah, this doesn't seem to help here either. You were doing programming? Well, yeah. This whole channel is reinforcement learning research done live. Okay, so this doesn't help. Go back to breakout. I mean, it is possible I've just done something screwy here. And the reward loss is very low. Yeah, but that doesn't seem... Okay, that definitely suggests there's an error here. What ID? This is just NeoVim. Okay, I'm actually suspecting I just have something wrong based on this. So I'm not going to abandon this just because I did it wrong. Let me see. Did I mess up the action logit or something? Sample logits. Decode actions. The hidden state. That actually seems like it should be fine. I do wonder if I messed up the reward loss, because that would also do it. Hang on, I could technically do this. I've seen all this for the first time in my life, so, well, yeah, you will be a bit confused. The whole idea of this channel here, I am a researcher. I do reinforcement learning research full time, and I build a whole bunch of open source software, and I do all of my development live. So people come by who use the library, they ask questions, people get involved in dev. I review code contributions live sometimes. The goal here generally is to just advance this branch of science. Well, that was stable for longer and then blew up. Weird. Very, very weird. How does this compare to like the Dreamer style? I don't want to abandon this just yet though. The Mu Zero style thing actually seems pretty good if we can get it to work. The fact that they train only on the world model seems really jank, right? Mu Zero trains on real data and uses more compute to get better real data, using the world model to like plan forward. It also gives you test time compute scaling for free. Dreamer uses a much larger model. The forward pass, or the data collection step, is very short. And then it just spins training for a long time. This is live research, right? I mean, I have a PhD in this stuff. I've been doing this like half of my life. Though the math side is actually my weakest part here. I'm far better on the engineering side. I mean, which of these makes more sense, or do they both make sense? So in one of these, you hallucinate a ton of trajectories and then train on them directly. And in the other, you hallucinate a bunch of trajectories. You pick which one you think is the best, and then you take the action according to that trajectory, right? Mu Zero seems like it should be way more likely to work quickly, I would think. You're not really changing the learning dynamics a ton. You're strictly using a world model to get better data with the simplest formulation of this. So you're scaling compute in order to get better training data. That seems that seems like this should be easier to get to work. So I don't think I should even think about trying to go to Dreamer today. I think I should just try to get this. For each game in Atari, 20 billion frames we used a lot. 2 TPUs for self-play. Equivalent to 2 weeks of training on 1 GPU. It's a lot of freaking training. They did 50 simulations per move. Okay. Is there an env where I would expect to need to plan? No, it shouldn't matter. I should just be able to use this on breakout and get better perf, honestly. I should be able, if this works, it should at least be able to match on that, I would think. Because the policy is stochastic, right? So this would at least give you the effect of determinizing the policy. Yeah, okay. If I tell it to take random actions, it blows up immediately. I don't know why I'm having. Well, I mean, it's mostly intended for technical audience, but this is, I mean, this is scientific progress happening live. If this thing works, then we will immediately have a way of scaling all of our AI training with compute way more effectively than we have now, and applicable to way more problems. So I usually on Saturdays I do like deep dives into crazy rabbit holes, and like I try to like look at something out there and see what I can get working in like the span of a day. It's kind of just meant to see like what are promising directions that we could take. Oh, if you want to see something cool that you will actually understand. So on puffer.ai, we have all our demos, which are mostly just a bunch of games, right? And these games are being played by neural nets that we trained live in your browser. And you can hold shift and you can take over and you can try to play, but you're going to not be as good as the agent for most of these. You know, we've got like this racing. This is like a superhuman racing AI. We'll see how quickly it responds to everything. And this is trained purely just by playing the game. This plays the game a whole bunch and it figures out how to play it. Same thing with like multi-agent snake. So we have lots of cool demos of this stuff. So what we're trying to do here is actually kind of easy to explain. The how of it is a bunch of math and a bunch of engineering. It seems weird to me that this would break training. Right? Because this is just saying take random, try from random actions. This is all this is saying, right? If I do like this. It's kind of a queue function. Kind of. It's not going to train either. Had a question regarding classification. If I have a bunch of features and a bunch of data points, but just a binary classification, do you think reinforcement learning is a good... No, reinforcement learning is never a good way to train if you have a supervised learning signal. Reinforcement learning is for when you have usually an interactive process with unlabeled data. So you're interacting with some sim, and then you basically just know every so often whether you did well or not. So you have a very weak learning signal. That's what reinforcement learning is used for. If you try to like throw reinforcement learning on classification, you can actually technically set it up, but it's way less effective than just doing supervised learning, because like reinforcement learning as a whole is a method of techniques for dealing with when you have very low learning signal, usually in like a non-stationary interactive process. If you have a strong learning signal in a stationary process, which is what classification is, you just use it. There's no reason not to. Okay, so this blows up freaking infinitely, huh? And then if I just do like this instead, gotcha, yep. So the cool thing with RL, right, and like the best way to understand it is this thing plays a game. It starts off by mashing buttons randomly, and it just gets better at it. And it just gets to be superhuman. Like one of the cool things about RL, you can just completely mess up the graphics of a game to a point that no human will ever be able to play it, and the RL won't even notice. It'll just learn to play the game exactly like it would with the good graphics. It's pretty cool. Okay, so this trains. It is when you increase the horizon that it stops working. Or it doesn't really stop working is the thing. In this case, right? It just doesn't do any better. And then on like Go, it doesn't really do anything. But then our implementation of that is kind of sketchy. I also want to learn all this from scratch. How can I? CS231N is the best like starter deep learning class, I would say. It's a graduate course, so there are some prereqs. They're considered basic prereqs for a course of this type. But yeah, you need like multivariate differential calculus, linear algebra, decent programming background. Like this stuff is incredibly cool, and we have people who came into PufferLib like a year ago with no programming background, not really any relevant math, and have done pretty darn well. But it takes work, right? Like I started doing this when I was 14 and pretty much just never stopped. Okay, so this still runs with this. But the entropy is like super crashed. So I mean, this just runs because it's not actually doing any search, I would imagine. If I just set this to 1, like this, I need to understand why this breaks it. Because this is just like, it should be able to evaluate which action puts it in a better state pretty easily. If it doesn't, then I probably have something set up wrong. Yeah, and then it explodes. Okay. I mean, there are really only two objectives added to this. I added these two losses. So there's a world model objective right up there. And this is just world model on state.hidden. Wait, world model of state.hidden. Does that make sense? Or did I mess it up? Do you come live every day at this time? I stream like 40 to 60 hours a week. There's not like a super fixed schedule, but I'm usually on because it's 40 to 60 hours a week. This bothers me. This really bothers me. I think that this one... Wait, neither of these are correct, right? Yeah, I think I just have both of these wrong. So if both of these are like a bit off, then neither of them are going to work. Okay. So then this reward model... Yeah, we need to just go rename things so that they're not dumb. I think that's what needs to happen right now. So this should be, instead of state.hidden, this is state.obs embed is hidden. Then this is state.hidden. Okay, so this is the same as before. And now we're putting obs embed into model state.hidden and then state, wait, world model of state.hidden has to predict obs embed. Is that right? I think this is correct, right? Because state hidden should be the output of the LSTM. And we want that to train to predict the embedding input. Hang on, though. The world model, doesn't it need... Does it not need the action? It needs the action, man. What are you doing? Okay. Right now I have it set up so that the input to the network takes actions, right? Hang on. Maybe I can make this simpler. If I just have like my standard network here, which is your LSTM, right? So S0, 1, S2, 1, and then this is like A1, B1, 2, B2, 2. Then from here, I just need something that predicts the input here, which is the next observation. So you really don't need, you kind of just need the action there. Can't I just have like a world model thing that takes in like, oops. Can I just like do something like this, where I take in like, and let's call this E1, so I take like E1. You don't even need to take in E1, right? You can take the output vector. Take literally the output vector. So this is actually, this S1 is actually technically H1, and then this is C1. So then I can take in H1, A1, and I can predict E2, I guess. Isn't this easier? Because then you don't have to change anything about the base net at all. I think this would be easier. And then the world model should actually have context for what I'm trying to do. Okay, let's try it that way. And then this can also predict reward, right? This needs reward and value, but it can do that then. Okay, we can do this. Let me go grab a cup of tea real quick so I keep myself awake here. This is thinking day. Smoke coming out of my ears. Give me a minute, I'll be right back. Okay. I think we can get this to work. I think we can get this to work. Say, man. I think it was the fact that I just didn't have this thing conditioned correctly. So what we're gonna do, we're gonna make the world model a little differently. And try again. So this is gonna be hidden size plus self-num actions going to hidden size like so. Okay, we no longer need action proj. We no longer need this. Just need like this. Okay. Encode observations. This gets state obs embed. We still need this for. It doesn't need this one hot actions anymore. Doesn't need this. It needs this. So we embed and we save this to here. Okay. Also, I need to not get dehydrated doing this. Had a lot of coffee. Let me do this before I get my tea. Okay. We do the LSTM wrapper now. You don't need any of this, right? So this actions actually gets added to the hidden state. Obs embed doesn't get used at all here. No, state.hidden doesn't exist yet. Yeah, state.hidden does not exist yet. We go like this. Now we've run the policy once. Now we have the hidden target. Doesn't super matter actually. Mu0 hidden equals. State.action dot repeat. You don't need this previous action anymore, right? You need to know actions at all? I only think you need to know actions for training, right? For training the world model. So I don't think you need to know this at all. Okay. You do need to sample some logits. So the first thing you need to do is actually sample logits, which is up here, right? And then you can one hot those actions, and then you can do input right here, right? mu0 hidden. And then this is self.worldModel, policy world model of hidden. And then this is like world model obs. And this is mu0 hidden. Then you get logits and values from decoding the actions. And then what do? You decode, you get the rewards from the hidden state. Comment this action, append the rewards, you append the actions. Okay. So it's something like this, I think. It's something a lot closer to this. And what are we doing forward for training? Obs embed is equal to hidden. This is not supposed to be here. It's actually, yeah, well, it doesn't super matter, but then state.hidden goes there. Okay. We got like 3 hours to get something to work here. I'm gonna do the best I can. I think we should be able to do it. Okay, so there's no state.hidden. It should just be hidden. This is in the world model bullshit, I think. No? World model obs? Okay. All I'm trying to do here is get like a nice self-contained world model module that takes in hidden state and action embedding and produces something that is going to be learned to be similar to an observation embedding. What are we still screwing up? Policy.world. Okay, cool. This is in clean PufferLib, which is right here. Now this world model, we can just do policy world model forward state.hidden and actions, right? And then what we can do is we can take this thing, we can do this, mu0 hidden, and then we can just add this function on here, which takes hidden actions, okay, and then this takes hidden, this is self-num actions, this is self-world model, return world model ops. Batch.action. I thought there was an action. Oh, it's not batch action, it's state.action. Action imp. Batch.actions. Colon -1. That seems screwy to me. I think this is just batch.actions. Okay, so expected some small mismatch shenanigans here. Presumably these are different shapes or something. Oh, so batch actions is, we should just return hidden after the transpose then, right? Yeah, we should just do that. Like this, maybe? Maybe just do this. Okay. This is correct. And it's just not dim equals 1 anymore because it's a sequence. It should probably just be dim equals -1. Right? Oh, I have Neptune on all these. Let's just do that. That'll be faster. Oh, that's so much better. Saves me a few seconds per run. Good. And state ops embed is the target. Next state shape. Ah, okay. State targets. You know, you really don't even need this here at all. You can kind of just obs embed goes after the LSTM, right? You can just do like right here. Batch tt state dot bed. Right there, before you get to the LSTM. That looks good. Next state creds. Next state targs shape. That's pretty good. Now this is concat on wrong dimension, I believe. So let me think about how this works. Obs embed. I think it has to be :1:. Like, yeah, like this. This should be the correct loss. And this is your world loss. Mean squared error, world loss. Hidden. Next. Threads. Targs. And you have your main squared error. And then similar for this, I suppose we'll quickly find out whether this is correct. Okay, so these are also messed up. State hidden shape is 128.64, 128. So you actually don't want any of this transpose bullshit at all. Huh? Yeah, I think we just do this. Okay, so now we have 128 by 64 by 1. And batch rewards is perfect. Squeeze. And this is of inflow -1. And then this is flow -1. Okay. So these should be better rewards and targs. Not the perfect result we want to see. Does something though. Next we will look at the actual world model here code. So I should be able to set this to like 0, right? Well, I need to refactor this so that this is the first iteration, basically. Is there a way that we could put this all one loop? Is there a way that that could happen? The thing is, you don't really need to call the world model. Let's verify something real quick. If I just do this, and I just do like state dot actions, we just do, oops, actions, log probs, logits, something like this. Does this train? State log prob. Oops, and this is action. Yeah, so this is the ultra fast train curve here. So I guess if we were to look at it this way, right? It's kind of like doing this. And this doesn't break anything, I'm sure, but. And then the stuff below needs to refine these predictions. So this is still good. Now the one annoying thing is that you do have to expand this to size n, I guess. So this is just going one ahead and looking at the value, right? I think I implemented this a little differently from U0 actually, right? I did this the more like PPO compatible-ish way. I mean, it is training here, right? It is actually training. You got your reward loss and you got your world loss. Hang on, I might have set this up wrong still. Because yeah, okay, I think I did set this up wrong. Hang on. I think I skipped one time step. Logits.repeat. Oh no, wait. So we take these logits, we repeat these a bunch of times, we sample different actions. Okay. We put these through the world model forwards. And then we put it through the cell of the next time step, mu0 LSTM state, which gets, this is the wrong H. Yeah, this is the wrong H. It needs to be, let's do that. Okay, it's not like rocket ship takeoff. Model, next time step. Oh yeah, but I think we're still trolling here. So world model forward, mu0 LSTM state, mu0 hidden C. Pretty sure this works. So you update your mu0 LSTM state. Okay, that makes it train faster. That's way better, right? That's not like perfect yet, but that's way better. Way, way, way better. Actually, that might be matching. Yeah, no, this is actually on par now. Cool. You get your new LSTM state. You decode actions from mu0 hidden. Oh, this is the old hidden. Oh, this isn't getting used anyways, I don't think. Yeah, this isn't getting used anyways. So when we go to multiple steps, this will break. So decode actions of 0. Hang on. Was this hidden? Okay, world model ops. mu0 LSTM state. This is mu0 LSTM state. This is mu0 hidden. mu0 hidden. Then mu0 hidden. Then you get your reward model on the hidden. You update your rewards. Let's make sure we didn't break anything. We're gonna get this today. We're gonna get it. This has gotta work, right? Okay, so this is... How the fuck did we just break it? Oh, we didn't. Hang on. Did we? No, we did break it. Let's go back to where it was working. Okay, this was the one that was working. We have to be very, very careful with this. Very, very careful. Okay, this is the good one. Now, this is your LSTM state. What if I just change this to H? Okay, so this breaks if I change that to H, right? Yes, definitely breaks. If I change this to H. mu0 logits, mu0 rewards. That's weird. So this goes, hey, if we sample a bunch of logits and we run them through the world model, it is correct to pass H here though. So I think that this is mu0 logits. Does this get used though? This doesn't get used. 0 values. The reward gets used, I guess. So how does this break? Oh, I guess it's because the value here is going to change, right? Yeah, so the value, okay, so that is going to change. So we sample logits from here. What the hell happened to our reward model, right? We're totally ignoring the reward that we get at this step. This needs to go on the hidden state here, right? This needs to go here. This is fast, good. Here, this still works. Be so careful. Okay, so this is the good one. So we're getting there. Now, you run the world model on the hidden state and actions. You get the new mu0 LSTM state. This decode should be on H. Apparently this breaks though. So let's see if this breaks it. Totally breaks it. Like, it still trains, but nowhere near as well. So issue here, right, is you're adding on this value bootstrap, I guess. Man. The thing is that this estimate should not be unstable. Yeah, the thing is that this estimate should not be unstable. If this estimate is unstable, then the world model has to be bad, right? How's the world model being learned? I guess that's the question. How's the world model getting learned? Cache. How about this? Learns, but not very fast. This is like just still so way off. And we know that like if we just put in the value that we actually get, then it's correct. So then the only errors in here has to come from errors in the world model, right? Because mu0 LSTM state oh wait, hang on. Yeah, it has to come through errors in the dynamics of next step. So obnoxious. This was 305, and this is probably like 300. But it takes forever to evaluate because now it's running through this whole freaking search. $250, it's even lower. But that's tricky. That's tricky. Because see, we should be able to like crank this. The goal is that you should be able to like crank this here. And like now it should be able to do this like multi-step modeling. Is this better than before? This actually seems decent, doesn't it? Hang on. Huh. So, I guess just compared to the original, there's a penalty when you use one time step because you may as well at that point just use the true value estimate and not have the world model drift or whatever. But if you roll ahead 4, like a few time steps, you actually get benefit. I mean, compared to the default, I don't know if this is getting benefit compared to... It's probably not going to get benefit compared to the original, but I mean, this is progress at least. Definitely progress. So they say that they use 5 steps look ahead for everything. We could try more step look ahead, or we could try bigger batch or both. So 800 at 28 mil, right? Yeah, so this is like pretty well on par with here. So potentially this can do something. I think if the benefit is, there's probably benefit from going deeper. Let's try this. Steps. I think that we have a correct implementation though now. I think we do have a correct implementation. We can probably scale the world model up as well. We're gonna try a few separate experiments. So this is deeper. Because we don't have frame skip in ours. pretty well on par with the other curves. We are actually using the actions, right? Log prob, mu0, yeah, we are giving it the actions. Okay, still behind our on policy version. Okay, so this is not like magically better. It's decent, but going deeper just makes it slower. It doesn't really make it better. At least on this. It's interesting. Okay, we could go wider as well, right? And go 128. So wider. We'll see whether this OOMs. This is too slow. Yeah, this is too slow to even run. This is probably like a scaling bottleneck. Let's try 64. Yep, that'll be better. It's like 200K or something. That at least we can run the experiment. I mean, it seems like there might be. It just seems like it's roughly on par, really. That's about it. like not getting a lot out of this model. Well, there are a lot of things we can ablate though with this, to be fair. Okay, like let's say we did 32. We scale up the world model a bunch. This thing. Yeah, it's stuck, okay. It's like about the same. Scale up the world model a little bit. You're supposed to do well with scaling. Okay, it's just redoing the optimizer. Okay, the reward loss is also still high, right? And that should be very easy to predict. That anything? Or is this the same curve? Pretty much the same freaking curve. World model loss is lower. Reward loss is still high. Maybe that's next. Okay, you know, this was kind of interesting. This is like... feels smooth. There's no way the reward loss should be that high, though. We stalled at 650? No, we're not. That's only about on par. just like on par. Not better yet. Hang on, we are still dependent on this reward model, right? So we're at like 0.14 right now on the reward scale for this. Let's see about this. You are very dependent on good world model and good reward function, so. So if this isn't better, then the question will be why not? Because it's like it's predicting the future. But it doesn't look like the reward loss has gotten better, which is suspicious to me. The reward loss in particular should be very easy to predict, actually, right? Yeah, the reward loss should be like very, very easy to predict. Okay. In that case, MSE over next reward predictions and next reward targets. Did I offset it by 1 by mistake? What happens if I do this? I don't think I did. I don't think I did, but we'll try this. Let me think about this. I'm almost sure it's the other way. Because you get the reward at every step. I mean, this doesn't seem to care which one you give it. It doesn't like do better or worse. It's the same graph. Which is also bizarre because it should matter. think this is correct any more than the other one. It's very weird that it doesn't seem to matter. Like, if the world model can predict you know, you're probably now getting just screwed by your sampling scheme here, right? Because you're not doing MCTS, you're doing something stupid. It's like a really dumb approximation. It shouldn't be a max. Should it? Or maybe it should be a max. It's kind of just rolling out a bunch of these. Maybe you have to like bump up the entropy a ton with this method. That might be a decent baseline. Let's go look at the MCTS scheme that they use in the meanwhile. Not this paper. Okay, so MCTS with upper confidence bounds. Every node of the search tree is associated with an internal state S. For each action, there's an edge SA that stores a set of statistics, respectively representing reset counts N, policy P, mean value Q, reward, and state transition. Action is selected according to stored statistics by maximizing over a probabilistic upper confidence bound. Oh, geez. Yeesh. That's something. That is something. There are a couple other things we can try before we go nuts with this. Because I think that's going to be... I mean, this is like the type of thing where they probably spent a lot of effort getting a fast GPU implementation of this. And there's like, yeah, there are a lot of different things going on in here. This algorithm is very powerful, though. This algorithm does feel very powerful. Okay, so this, we are going to let this finish because what I want to do is I want to compare this to 0.05 entropy without MCTS. So basically, like, if I make the policy more stochastic, does MCTS do better than, or not MCTS, whatever search thing I'm doing, does it do better than the baseline? And in the meantime, I also want to see, look, this reanalyze thing. Mu0 revisits its past time steps and re-executes its search using the latest model parameters. Ooh, that's hard. Yeah, that's hard. Okay, that's hard to do with the on policy formulation that we have. They do have n equal 10 step bootstrap. It does kind of make you wonder. How much you needed MCTS. Okay. But it should definitely be doing better on a samples axis, right? Even with only 6 simulations per move, mu0 learned an effective policy and improved rapidly. So we should actually, we should very well see we have this. What if I just go to mu0? This should be the fast one. So just do this. It's just so much faster. It's crazy. Yeah, it looks like this thing is still just going to be better, huh? Oh, it actually just matches like close to perfectly. Am I somehow just not doing anything with this? I wonder if we're like somehow just wrong in here. Let's look. Because we should definitely see with 32 sims, we should see something, right? Do rewards plus value, argmax. Okay, so yeah, so these indices are supposed to be the best rollout according to the policy, right? The returns max is 5, which is completely impossible, right? Yeah, 5 is completely impossible. Hang on, the reward function there are a few more things that just like don't add up here, I think. So data policy reward model of state.hidden, right? State hidden is hidden, okay? That should be differentiably optimizing through the whole net. That should be a very good prediction. And then, I mean, there's no reason not to optimize the world model through the net, right? Unless there is. If we do this. Okay, and while we run that, I need to really think about this reward loss and what the heck could possibly be wrong. Wait, is this the wrong state? Hang on. This is state hidden. No, this state hidden should go into the reward loss, right? State.hidden. Reward model goes on to state. Hang on. Plus equal rewards. Reward model on the hidden state. And it's mu0 hidden, which is the output hidden state. This doesn't get updated. Okay, this doesn't get updated, so this is completely screwed. This is worse as well without the detach. For corrupting the objective. Okay, so we'll see what this does. The two things to look at should be the world loss and the reward loss. Do we think this is correct yet? Mu0 hidden. So this is now the next hidden state coming out of the cell. This gives us reward prediction. We predict reward. We sample. the append actions that came from mu0 logits. Okay. I think we've corrected it, but now it doesn't work. Reward loss is about the same as before. It gets applied to hidden state. State LSTM H equals hidden. Forward. State hidden. And it gets set there. I do not like this reward loss. I really don't. This feels like there's something very wrong with it. But it's gotta be state hidden is what you get as the output from this forward pass up here. And then your target's just the reward, batched out rewards, right? And you want the reward that is, you want to cut the first reward off, right? Seems right to me. It's not like it isn't training, it is, but you know, the entropy is very low now. I'm noticing. I could do random action and then follow policy. There's gotta be such low variation in the, yeah. We could do epsilon greedy technically. Okay, it's not like this search doesn't work. It does. It's just not efficient. And it's probably because of this. Okay. Percent. It's like a quick epsilon greedy, right? It is going to mess up log prob. No, it isn't. No, it isn't. It's fine. The reward loss is still the thing that bothers me. It's like way too high. We're learning something here. I don't know if this curve's any steeper. This is with epsilon greedy on. Seems like it probably isn't. What would be like a quick alternative sampling scheme I could use here? I could do mean reward under policy instead of best. Maybe that's more robust. Because this is worse, right? This is like way worse, right? Yeah, this is worse. Okay. So epsilon greedy, bad. Wait, returns shape 32. How do we group this nicely? I mean, I can write a really stupid loop, right? I can't freaking do this. And find another thing I can do instead. This is just gonna be like, this shit is just not easy to write with torch tensors at all. Like you need to write a freaking CUDA kernel for this. It's like so much harder to write torch than it is to write CUDA, ironically, for this. Like you need to just be able to write arbitrary loops and stuff. It just work as the way it's written. It really seems like it should at least do something the way it's written. Try it again on Go, but I don't really trust that end as much. Argmax should be totally fine. Is like a basic version of it and should be totally fine. I guess I haven't tried going deeper since I fixed it. So I can technically just see if this does anything. I doubt it. But maybe. Because like 5 is a tiny number of steps to look ahead and break out. It could be that there's just nothing that looking ahead 5 does for you, to be fair. This reward loss is pissing me off. I don't understand how it's not, like, perfect. The world loss is, like, really low, right? Like, this thing should have a decent grasp on the next obs. Well, to be fair, yeah, in this end, they're not, like, that would kind of make sense, I guess. It should kind of tell me something that so far I exactly match PPO, right? That should, like, be weird, right? I mean, that could just mean that you're not really limited by picking bad actions in the training here, right? But that wouldn't make sense. You should be limited by picking bad actions. Yeah, this looks like just on par with the best non-search curve. Right, 360 at 13 mil. This is just, like, on par, right? Yeah, it's right over there. I mean, I could do, like, fewer ends, maybe? Maybe that's the trick. We, like, downsample M's by a factor of 32. It could work. I mean, like, what if, yeah, what if we just have so many parallel m's that we just have a perfect estimate of everything for this env, right? Because actually, like, this run isn't bad. Like, it seems like this does something. But it could just be that we already have perfect estimates of everything here. I say, and then this, like, takes a little dip. Okay, I want to try something. $64 total M's. I might have been a little bit too low. We'll see. So the hope with that was like, you need to have a decent number of parallel computations in order to use your hardware efficiently. But like the MCTS kind of does that. Well, this doesn't seem to be particularly fast at all now, does it? If we assume optimal batch is 32K for very small nets, yeah, I think I probably went too low on this. Because this is going to take forever. Like, Jesus, that should be at least 4x faster. Let's try this. Oh, you know what? I think the real alpha would be, so you divide this by 8, right? And then what if you just divide this by 8 as well? $65. Same mini batch size, do we think, or do we go way smaller mini batch? We can't go way smaller because of the BPT horizon, maybe, right? Okay, so this trains at 100K steps per second. Which is quite slow. Can we get better training out of this? Okay, so this seems like it does something. Maybe. But then the question is going to be if we just don't use MCTS, we get the same thing. Yeah, so this is going to be dramatically more sample efficient if it continues on this trend. I suspect what's going to happen is the on policy is just going to work just as well. You kind of have to be limited by like very small batches or something, I think. Also, this isn't performing as well as it should. Seems like this is just unstable. Yeah, this is just messed up. So I don't know what happened that got it stuck here. That's weird. Can't even do this. Let me think if I can pick a different problem where I would know for sure. The thing is, like, we kind of just get perfect gradient information because we have these massive batches. We really do. And then we have advantage filtering that throws away the stuff we don't need anyways, right? So like if you're training with a tiny batch of data maybe, kind of recovered. That seems like optimization screw up. It was on pace to be faster. I guess I could try the normal PPO on this without search. Just see like the initial curve maybe. This looks like it's just better. Yeah, this is just like straight up better, right? So yeah, this is not even like a thing where I guess I could try to solve it with like tiny batch. That could be like a decent thing to do. Because then you'd definitely be at the mercy of, yeah. This is probably just going to be unstable because of normalization, though. 4096. House batch size? 64, that still seems big. 64. That's still big. No, that's correct. So we do like 64 M's for 64 steps. See if this even trains with PPO. Yeah, I forgot about that. There's literally a min M's requirement. How's this still an issue? Total agents. Ah. You need, yeah, you need 32 total M's, which means like I just want to see if this does anything. Hey, bet. Trying to get model based to do something. So far, it's not doing anything. Like, it's working, but it's not any better than model free. Well, have fun with that. Steps, threads per block. That's super obnoxious. Isn't 8? Wait. Times 8. 64 times 8 is 5. Yeah, so this is literally... You can only have 8 threads, I believe. It's so stupid, but we're gonna try it for the sake of it. I have to run. Well, I'm not sure here, if basically we just have so much freaking data that there's just like no point in trying to get better data because we just have all the data we could possibly need. I don't know. What I'm doing now is I'm just reducing it to a ludicrously small batch and seeing. Oh, this is cached. I'm dumb. The thing that's weird to me, right, is they use this on Go, which is like a ludicrously fast environment if you implement it well. So like they didn't care about the number of steps in which they solve Go, right? They were just trying to solve it. So you would think that this would do something. The fuck? Well, that's not doing shit. I thought I'd fixed that bug. I thought I had fixed that bug. This is... Isn't this just like 40? No, dummy. 160. Yes. Dummy. Fucking bugs, man. I can't even test shit. What? I wasn't dividing. Yeah, I know. It doesn't work because of shitty bugs. But I can't fucking fix it here because it's like so obnoxious. I can do this, but I think that this just like is going to give me invalid experiment results. We'll see, I guess. It's 447. I don't want to try like the learn in hallucinated bullshit version. This algorithm makes sense. I would think that it should work. It doesn't not work either, I guess. Let's go back to the version that actually makes fucking sense. Let's go back to the version that makes sense. Okay, so this is how it's supposed to look, right? $360 at like 13 or whatever mil. What if I do this? So look one extra step ahead. The world model is trained one step ahead. You still train at a mostly reasonable speed. And you stop learning. You no longer learn remotely quickly. If I increase this to 5 or 10, you recover the original curves. That seems screwy. So you get plus rewards. The reward that you expect to get. And then you get the value in the next state. There's definitely something going on here that, like, you recover the original performance of the algorithm if you increase the rollouts. There's definitely something going on with that. Let me think about what that means. So why would perf degrade versus the baseline is the thing. So we're checking the reward that we expect to get, right? Oh, hang on. Don't we need... No, these are the correct actions. But this reward model is wrong, isn't it? Hang on. How can you have a reward model based on the hidden state like this? This needs to be, the world model here needs to be predicting the reward, doesn't it? Because it has the hidden state, and it has the action. So let me try that. Let me try that. Okay, so now this is the thing that's going to predict your rewards, right? Let's see how this goes. So your world model So you sample your logits, right? You append, and then this is going to give you, okay, so now you actually have correctly conditioned reward. This could have been the issue, to be fair. This totally could have been it. So then this is next reward threads. What do we think about this? Okay, so this now runs. Let's see if that makes a difference. Now the reward model is correctly action conditioned. Still nowhere near in perf, right? The reward loss is not better either. Totally should be. Hidden is world model shared. You do world model, you do reward predictions, right? Be fine. So this gives you your next observation and the reward for this observation. And then you can compute the value in your next state is the idea, right? Yeah, you compute the value in next state. How does the reward loss not get better from being action conditioned? That seems to me like it's just not predicting the right reward, right? I'm pretty sure it is, but that loss is sketchy. Use 0 actions. It's supposed to be predicting the next reward. And then this thing's crashed totally. It's supposed to be predicting the next reward. One reward in advance. Yep. Well, you roll it out, so it can do that repeatedly. Yeah, it's gotta definitely be next reward. No, you're not predicting 128 rewards. You're just predicting, right now, 1, but usually like 5 or 10 rewards. Maybe this one you should back propagate. Kind of hard to do that. Wait, you dummy. Isn't this forward train? That shouldn't, none of that matters. Yeah, none of that matters at all. It should not be hard to predict the next reward. It should be very, very, very easy to predict the next reward. So like 0159 is just random uninitialized garbage. And it inputs, targets, inputs, targets. It's correct. Is there any chance I'm computing the actions wrong? That would totally screw it up though. Like it wouldn't be partially fine. Something's so wrong here. Like it does optimize and then it goes back up, I guess. Didn't optimize particularly well though. Not at all. Right? For what should be a very easy loss. Was this computed? Rewards come from... Well, you don't need to detach jack shit in here because this is the forward pass. This is all detached anyways. And then the forward here, mu0 hidden is what this gets applied to. So mu0 hidden is the initial LSTM state that comes out of the policy and actions as well. The hidden state coming out of the policy into the actions. That's like a random reward prediction right there. I'm pretty sure. Maybe not, to be fair. Maybe it's substantially better. It probably is substantially better is the thing, because the number of rewards goes up a ton. Yeah. You know, actually, that is possibly decent. Okay. I'm gonna run this again with 5. We haven't done this in a while. While I think about this, you have your world model. What about values? Value is action agnostic, right? Yeah. Could technically just do it over values or just do it over rewards. Probably be just over rewards, right? The fact, though, that it didn't decrease the reward loss at all. I guess maybe it's just a tiny action decoder, so it kind of knows what it's going to do anyways. That wouldn't be crazy. Be pretty reasonable. What happened to episode return here? Not doing well. There's a reward network that's separate. Yeah. It's just, there's a separate goal of just predict next reward. I could technically do it just on the value function, right? Not really. You kind of do need reward. Okay, so now this is worse than before. With the corrected action model, it's worse than before. Let me see if there's anything I can do to bring this more in line with how mu0 works. So I think that they don't send it through the model. Right? I don't think that they have a target on the world model itself. I think theirs is like a separate network, right? That just outputs state and reward or whatever. State, action, reward. So what would that do if I just had a separate thing doing state, action, and reward? It would just take action as input. You'd probably use the LSTM state or something as the input. We could try that, I'd be down. It's 5:16, I've got an hour. Maybe that makes it more stable. I want to commit all this. So we make the world model a separate network, right? No, not at all. This needs the LSTM bullshit thing, doesn't it? Yeah. It should be easier than the other ones. It kind of should be a GRU, right? Does it matter? I don't think it matters actually, does it? I think we can just reuse this, probably. I don't have to screw with the GRU. Hell's wrong with this? So is it just... Okay, so this is the cell, right? It's got the cell. And then it needs input, action, embed. And then world model forward, it's actually going to take actions and then hidden state, and then it will action, self to action embed actions, hidden, let me go find how this works. It's TMC. State. And then hidden state gets to be, so action equals action head of the hidden, reward head. It returns actions and rewards and state. Okay, so let's think about this. We can just put this in the LSTM one, right? Yeah. This takes actions and state and returns actions, rewards, and state, which is actually, it should be logits, rewards, and state. That's what it should return. Logits. Right. So this is world model logits. Okay. And then this has to take 0 actions and move 0 hidden. And then the hidden should be the hidden state of the model, or should it be the embedding? I kind of like making it the, we'll give it zero h equals obs embed state.obs embed use 0 c state. Okay. So sample your logits. And you have your logits, your rewards, and your state. This rewards. This is state. Keeps rolling forwards. Then 0 hidden. You no longer need this because, yeah, this is done. This is done. You do need values, don't you? I think you do need values. Yeah. Value head. Value state. That's pretty close. Now in clean PufferLib, get out of here, bot. Okay. So we actually do need to define this thing like this, but for the world model. So easiest way to do that, puffer GRU. I realize it's not going to make a difference. This is forward. Okay, we have forward train. This shit's completely fine. Shit's completely fine. Code observations. Oh, I'm realizing we can literally get rid of all this now because the new API. That's gonna be nice. Yeah, there's no encode observations, right? Because you just give it the actions or whatever the hell. I guess it's action emp. I think we need any of this shit. Maybe that's enough. Now hidden. I mean, does it freaking matter? Can I just skip all this shit? You don't need to decode actions here. So you just do okay. That works for state. Okay. I think it's something simple like this. We're gonna have to debug this into existence in the AS code. Stop. Neptune needs to not fucking take forever to initialize. So you do need obs embedding now, or what? You need obs embedding just to initialize. Just to initialize, I think. Okay. Cannot address world model state. Hey there, how's it going? We're doing all right. We're deep in model-based RL territory here. Is this the correct initial state? I don't think it is. We need to get this state equals, yeah, this. Okay. 54. The fuck? Probably some shape bullshit. That is not supposed to happen. Does state get transposed? State get transposed? I don't think state gets transposed. No, it doesn't. So you give this thing time and then batch, which is what I gave it. Why is this 128 object? Expected hidden of 0 size 1. Oh. Yeah, hang on. And this state LSTMC isn't going to do shit either, right? This needs to be zeroed. Is this even getting trained correctly? Hang on. Yeah, I mean, technically it is, right? But, it doesn't have a cell state to start with. I guess it just starts with 0 for cell state. Why is this the shape of this stupid thing? I guess it's like... can do this. And then it'll be like this, maybe. That ought to be right shape. Fuck's sake. How about just zeros like obs embed 0? How about that? Drive me crazy. Five. Too many values to unpack. So this is going to return logits. We don't need logits, right? We just need, I don't know, what do we need for this? I think we literally just need state, target, reward target, and state target, right? Well, we need value targ. How the hell's the policy get trained then? Wait, what? Okay, so now we can do, finally, next state preds is this world model state 1 state word loss We also have the freaking world model policy loss, don't we? I guess we'd want to like behavioral clone this thing or something. What does it train the logics on this to? It's the objective on the policy world model. So we just we have the Diane loss that we were using. I have to get these indexes right. HC. Which one of these are you freaking using? There's no more obs and bed loss, right? You just don't do this anymore? So can I just... I don't think you need, I think you can just use... Can you not just use this? You know, and you put the... It gets the observation in. starting from the state, which gets an obs embedding. So it gets the first obs, and then it's going to produce Does this thing have a policy on it? It has to, right? So I guess that's like the previous action or whatever. Now this is the action that's going to produce the next state. So you took this action with this obs. Okay. And then the reward, this makes sense that this is offset. The value function is, I think that this is just this. I think the action's also just like this. Come on. Value loss. New value. Okay. It's better. Okay. We're now actually maybe getting somewhere. I don't think we're doing anything remotely sane in the forward pass over here, right? Oh no, we are. So we just sample, we just roll out through the world model, and this kind of does stuff, I guess, right? And we probably want to train this thing with like the same value loss, I guess. How do we want to do this? I mean, you have this like extra thing now. Yeah, so I kind of see that this would be way simpler. This would be like way simpler if your policy weren't recurrent, because then you use the state to represent the world model, but it has to be separate because of that. Okay. I have a crazy idea and I'm not qualified to build it. Sure, go ahead. It's crazy, this does actually kind of train. Reward loss. So that's going to be squared error with the actual reward. That's easy. I don't advocate that particular slogan bet, but I would just say to learn the damn stuff. You could very easily do something that pretends to do that um, with the language models, and it would just be like bollocks. It would just all be smoke and mirrors. It would have like no predictive power of anything. It's even remotely possible? No, not at all. It's kind of like there's like a lot of adjacent language model stuff that's like really flashy looking, but just doesn't make any sense if you think about it for a few seconds. Man. So we just have to fix these losses now, huh? Probably this doesn't need to be clipped, to be honest. But then what do we do with this? Does this just need, I got rid of the encoding piece, which is good. Supplementary figure 2, which is not in here. Where's the non-shit version of this? I don't know why they publish so much crap in Nature. It's like, their format just sucks. They have this on, yeah, it's on archive, and now you can actually read it. Yeah, here you go. The Nature paper format is just bullshit. No, I think it's the opposite. I think there's a strict page limit. Isn't it? The hell is this? IT. Huh? The fuck? Oh, this is their bucketed thing. We don't have to care that much. Okay, squared error loss. And then we can make the world model bigger. I don't think that's could be the issue. I don't know. This thing is supposed to scale. It's pretty cheap to train this as well. It's the inference cost that'll get you. Isn't the reward loss higher than before? Hang on, this gets H as the obs embedding, and then C. There's no C, because it's zeros, right? On first step. Well, hang on, how's this? This is training to predict next reward. Right? Yes. The value function is training. I think I gotta go for dinner. Value function is training to do. So you do, the value function needs to be trained to predict the next value, I believe. Try that. I don't think that'll do anything, but we'll see. Okay. We will continue on this. We will continue on this afterwards. Let me go double check, see if it's dinner time. Okay. I will be back after dinner. Thanks for tuning in, folks. There will be hopefully a little bit more world model stuff later tonight. I'd really like to get this model working. I was going to invest a day in it for now, and then we'll come back later. But all my stuff's at puffer.ai. You can check out all open source code. If you want to help me out for free, start the GitHub. If you want to get involved with development, join the Discord. Some of our best contributors came in with 0 RL experience. And if you want more RL content, you can follow me on X. I post all sorts of things there. Other than that, thank you, and see you around.